What if the strangest visitor our solar system has ever seen never truly left? And what if the thing scientists have been quietly tracking above our heads right now is the same object we lost sight of years ago? Because something in the sky has just shifted, and the people who study it for a living are not sleeping well tonight. If your heart just skipped, do me one small favor before we go further. Tap that like button, hit subscribe so you never miss a story like this, and share this video with one person who still believes the universe is trying to tell us something. That single click helps more than you can imagine, and it keeps stories like this alive. Now let me take you back, because to understand what is happening in the sky above us today, you need to feel the weight of what happened almost a decade ago. It was October 2017, a quiet Hawaiian night. A telescope called Pan-STARRS was doing what it does every evening, scanning the sky in slow, patient sweeps, looking for anything that moved. And then, on one frame, there was a tiny smudge of light. Not bright, not dramatic, just a small dot crossing the darkness. Nobody at that moment realized they were staring at something that would rip a hole in modern astronomy. The astronomers who first noticed it did what astronomers always do. They ran the numbers. They calculated its path. They tried to fit it into one of the familiar categories, a comet from the outer solar system, an asteroid from the belt between Mars and Jupiter, a piece of icy debris from beyond Neptune. And every single category refused to hold it, because when they finished the math, the answer was not just surprising, it was almost impossible. This object was not moving on a closed orbit around our sun. It was moving faster than the sun could ever hold. It was on a hyperbolic path, which is a scientific way of saying it was passing through, not sticking around. It had come from somewhere else, somewhere far, somewhere outside our star. For the first time in recorded human history, we were looking at an object that was born under a different sun. Think about that for a second. Every rock, every comet, every dust grain we had ever studied belonged to our own little cosmic family, born from the same cloud of gas that made our planet. But this thing was a stranger. It was a traveler, and it had wandered into our neighborhood by accident. We gave it a name that felt right for the moment. ʻOumuamua, a Hawaiian word that means scout or messenger from afar, and for about 3 short weeks, humanity chased it with everything we had. 3 weeks. That was all the universe gave us, because by the time we understood what we were looking at, it was already leaving. And in those 3 weeks, this quiet little messenger did things that made some of the smartest people alive genuinely uncomfortable. The first shock was its shape. Every asteroid we had ever imaged looked roughly like a lumpy potato. Every comet we had ever seen looked like a dirty snowball with a glowing tail. But this thing looked wrong. Depending on how sunlight bounced off its surface, it appeared either extremely long and thin, like a cosmic cigar, or completely flat, like a pancake tumbling through space. The proportions were so extreme that if it were a normal rock, it should have shattered under the stress of its own spin. Yet it kept turning, calmly, silently, as if the laws of physics did not apply to it in quite the usual way. The second shock was its silence. Comets scream when they get near the sun. Their ice melts. Their gas explodes outward. Their dust forms those beautiful glowing tails that stretch for millions of miles. Oumuamua passed close to the sun, close enough that any normal comet would have lit up like a torch, and it did nothing. No tail, no coma, no dust, not even a whisper of gas that our best telescopes, including the incredibly sensitive Spitzer, could detect. It was as if this object had no ice at all, as if it was made of something we did not yet have a name for. And then came the third shock, the one that broke the peace inside the astronomy community. As Oumuamua rounded the sun and began racing back out into the dark, it sped up. Not the small, predictable speed up you get from gravity, something extra, something more, something that pushed it faster than the sun and the planets alone could explain. And when scientists went through every normal reason for that push, every single one failed. It was not radiation, pressure from sunlight. It was not the solar wind. It was not thermal venting. It was not 2 rocks stuck loosely together. One by one, the usual suspects were ruled out. And when every ordinary explanation collapses, you're left standing at the edge of a very uncomfortable question. What if it is not ordinary at all? That is the moment when Professor Avi Loeb stepped forward. And I want you to understand who this man is before you judge what he said next. He is not a random voice on the internet. He is not a hobbyist. He was the chair of the astronomy department at Harvard University for 9 years. He has published hundreds of peer-reviewed papers. He is one of the most cited astrophysicists alive on this planet. And when he looked at the data, he did something almost no scientist at his level had ever done in public. He said, out loud in peer-reviewed journals, that the best available explanation for Oumuamua might not be natural at all. It might be technology. Specifically, he suggested it Could be something like a light sail, a thin, wide, artificial structure designed to be pushed by the pressure of starlight, the way a boat is pushed by wind. Something built by minds that were not human, floating quietly through the galaxy, and by pure chance, drifting past our small blue world. The reaction was fierce. Many of his colleagues pushed back hard, arguing that we should never jump to an extraordinary answer when a natural one might still be found. And honestly, they had a fair point. Science is careful for a reason. Extraordinary claims demand extraordinary evidence, and Loeb did not have a photograph, a signal, a piece of the object. He had data gaps, strange behavior, and a refusal to look away. But here is the thing that many people missed. Loeb was not saying it definitely was alien technology. He was saying we should not close the door on the possibility just because it makes us uncomfortable. And that is a very different argument. That is a scientific one. Now, take a breath, because we are only just getting started. And if this is already pulling you in, if your mind is racing right now trying to figure out what is real and what is not, do this for me. Drop a comment below with just one word, the word that describes how you feel right now, curious, scared, excited, whatever fits. I read those comments. They help this channel grow, and they help me know what stories to bring you next. Now let us keep going, because the story took an even stranger turn after 2017. For years after Oumuamua vanished into deep space, the argument raged on quietly in academic journals. Then, in 2023, two researchers, Jennifer Bergner and Daryl Seligman, published a study in Nature that offered what they called a simple, elegant explanation. Their theory was this: Oumuamua had traveled through interstellar space for millions, maybe hundreds of millions of years. During that endless journey, cosmic rays had constantly slammed into its icy body. That radiation slowly cooked hydrogen gas into the ice itself, trapping it deep inside. And when Oumuamua finally warmed up near our sun, that stored hydrogen began to escape, silently, invisibly, because hydrogen is one of the hardest gases to see. It carries no dust, it gives no color, it produces no tail our telescopes could catch, but it still pushed, like a tiny, invisible jet engine hidden inside a strange little rock. They called it a dark comet, a comet that behaves like one but hides its own evidence. For many astronomers, this was the exhale the community had been waiting for. Finally, a natural answer. Finally, no aliens required. The dark comet idea fit inside known physics. It did not stretch the rules. It did not force anyone to consider the uncomfortable possibility that a piece of somebody else's civilization had drifted past our planet. But Avi Loeb was not satisfied. And this is where his argument becomes almost impossible to dismiss, even for people who do not share his conclusions. He pointed out something painfully simple. The dark comet theory says Oumuamua released enough gas to accelerate itself, but that this gas was completely invisible to every instrument we pointed at it. In other words, the evidence that would prove the theory is the same evidence that cannot be seen. That is not a satisfying scientific answer. It is possible. It is not disproven. But it leaves a hole in the logic that Loeb refuses to paper over. He also raised a deeper concern about the culture of science itself. Young astronomers, he argued, feel pressure to avoid the alien technology question completely, because being wrong about it could end their careers before they even begin. Nobody wants to be the person who claimed a rock was a spaceship. So the field defaults to the safe answer, even when the safe answer has cracks. That is not a conspiracy theory. That is a real observation about how scientific communities behave under social pressure. And it is one of the reasons this debate is still alive today. Meanwhile, Oumuamua itself is now somewhere far beyond the outer edge of the Kuiper Belt, racing away from us at more than 85,000 miles per hour. It is expected to cross the boundary of our solar system, the heliopause, in the late 2030s. We cannot chase it. We cannot sample it. We cannot bring it back. The window closed the moment it passed. But then, just when many people thought the story was fading, something else happened. In late 2019, a second interstellar visitor arrived, a comet named Borisov. It was larger, richer in ice, and behaved exactly like a normal comet. It had a tail. It had a coma. It looked and acted like the comets we already knew. And for many astronomers, that was reassuring. It said that other star systems make comets just like ours. It said the universe is consistent. It said, calm down, everything is fine. But then, in July 2025, a third visitor arrived. And it changed the mood inside the astronomy community almost overnight. Its name is 3I Atlas. And unlike Borisov, which behaved politely, and Oumuamua, which behaved strangely, this one behaves like nothing anyone had prepared for. Astronomers had spent years modeling what a third interstellar object might look like. They assumed it would resemble either Oumuamua or Borisov. Instead, it looked like something completely unfamiliar. It arrived moving at nearly 130,000 miles per hour. much faster than anything predicted. That speed alone hinted that it had come from somewhere deep, ancient, and far away, somewhere near the old core of our galaxy. And then came the age. Early analysis suggested this object might have been drifting through the galaxy for 10 to 12 billion years before finally passing by our sun. 10 to 12 billion years. Let that sink in. Earth is only about 4.5 billion years old. This object began its journey long before our planet, our star, or even the raw materials of our solar system existed, and its size only deepened the puzzle. Hubble space. Telescope observations placed its nucleus somewhere between about 1/4 of a mile and roughly 2 miles across. Compare that to Oumuamua, which was maybe the length of a football field. If the estimates are right, 3i Atlas could be up to 1,000,000 times more massive. That is a statistical earthquake. Because if interstellar objects follow the size distribution we expect, we should see many small ones for every giant. 1. We should have seen tens of thousands of small drifters before ever spotting a monster like this. And yet, we saw one small one, then a moderate one, then a giant. The pattern does not match the models. Either the models are wrong, or we are seeing a very unusual sample, or both. And then the composition data came in, and it made things stranger. Observations detected an unusual abundance of carbon dioxide and, more surprisingly, nickel. Nickel is a metal we associate with industrial alloys, and in extremely small amounts, with certain natural comets. Finding it in noticeable quantities in an interstellar object was not what anyone predicted. Loeb pointed out that the composition looked closer to what you would expect from a nickel-heavy alloy with very little iron, the kind of ratio you would find in specialized engineered materials, not in a typical space rock. Now, to be fair, nickel does show up in nature. Some solar system comets contain traces of it. The full compositional picture is still being pieced together, but when you place this one anomaly alongside all the others, you start to see why serious scientists are choosing their words very carefully. And then there is the jet. The most puzzling thing of all, comets vent material outward, away from the sun, because the sun heats their sun-facing side and blows the gas backward. That is basic physics. It happens every time. But 3i Atlas seemed to eject material in the wrong direction, toward the sun, not away from it, toward the source of heat instead of away from it. That behavior does not match any comet we know, and so far, no one has offered a fully satisfying natural explanation for it. Studies continue, data keeps arriving, and every new piece raises another question. If your brain feels a little overloaded right now, that is completely normal. And honestly, that is a good sign. It means your mind is still wide open, still willing to sit with uncertainty. So before we go into what happens next, and yes, there is more coming, do something small that means a lot. If this video has held your attention this long, that is not by accident. That means you love mystery, science, and big questions. So take a moment right now to hit that subscribe button and turn on the bell, because I promise you, the next video we release is going to blow your mind even more than this one. Trust me on that. Now let us go back to the story, because this is where it starts to feel personal for humanity itself. In late 2025, something extraordinary happened. Astronomers monitoring the sky, using the new Vera C Rubin Observatory in Chile, picked up a signal that seemed impossibly familiar. The trajectory matched, in an eerie way, the last known path of Oumuamua before it vanished. The size estimates matched. The reflection curves matched. And the tumble, that slow, strange rotation that had puzzled scientists for years, matched too. Officially, the object is being catalogued under a temporary designation while confirmation continues. But within the astronomy community, a whisper began to spread. A whisper that has grown louder every week. What if Oumuamua came back? What if it never really left? What if the object we thought was racing away forever has somehow turned or slowed or been captured by something we do not yet understand and is now returning through the outer edges of our system, glowing in ways it did not glow before, moving in ways it did not move before, and carrying with it an even bigger mystery than the one it left us with in 2017? I know that sounds dramatic, but the reason scientists are taking it seriously is not the drama. It is the data. Because when they compared the newly observed anomaly with the archived data from Oumuamua's original flyby, several key signatures lined up in ways that pure coincidence struggles to explain. The angle of approach, the pattern of light, the behavior of the surface. And here is the part that is difficult to say without sending a shiver down your spine. The new object appears to be accelerating again, not from gravity, not from any obvious solar heating. It is speeding up in a way that echoes exactly what Oumuamua did in 2017. That same invisible push, that same silent nudge from something we cannot detect. Some astronomers are cautious. They remind everyone that space is enormous and that similar-looking objects can appear by chance. They warn about jumping to conclusions. They stress that we are still gathering data, still checking every possibility, still trying to rule out simple explanations. And they are right to do that. That is how good science works. But others like Loeb and a growing number of independent researchers are asking a harder question. What if the same object really has returned? What would that mean? Because a naturally tumbling piece of interstellar rock does not turn around. It does not slow down. It does not come back. It obeys the same laws that sent it away in the first place. If this really is Oumuamua, then either our understanding of interstellar dynamics has a major gap, or the object was never fully natural to begin with. And here is where the story feels almost too big to hold. Because whether or not this particular object turns out to be Oumuamua returning, the pattern of interstellar visitors is now impossible to ignore. Before 2017, humanity had never seen a single confirmed interstellar object pass through our solar system. Not one. Then, in the years that followed, we saw 3, one after another, each stranger than the last. And now, the new Vera C. Rubin Observatory, which came fully online in 2025, is expected to spot between 1 and 3 new interstellar objects every single year going forward. Every year. That is a completely different picture of our place in the universe. It means our solar system is not an island. It is a busy crossroads. Things drift through here all the time. We just could not see them before. And now that we can, we are discovering that the universe is a lot more interconnected and a lot more crowded than we ever imagined. Take a small pause here, because I want to ask you something. If interstellar objects have been quietly drifting through our solar system for billions of years, and we never had the eyes to see them, what else has been quietly passing us by while we were sleeping? What else might be out there right now, moving slowly through the outer dark, waiting for us to lift our heads and notice? If that thought excites you, if it terrifies you, if it makes you feel small in the best possible way, then please take 1 second to tap that like button and share this video with someone who deserves to feel the same wonder. Because the more people who see this, the more the story spreads and the more we push back against the silence that surrounds these questions. Now let us keep going, because the next part is where everything begins to connect. There is a growing conversation among physicists and astronomers about a project called Project Lyra. The idea is simple but breathtaking. Send a spacecraft after Oumuamua, chase it down, fly close enough to see what it truly is. Engineers have already calculated a possible trajectory that could launch in the early 2030s and arrive at the object by the late 2040s. That is not science fiction. That is engineering. The technology exists. The math works. The only missing pieces are money, willpower, and political commitment. And now, with the possibility that Oumuamua may have returned in some form or that another similar object is entering our system, the urgency has climbed. Because we might not have to wait until 2048 to get answers. We might get them within the next few years if we act. Some scientists have proposed something even bolder. Using the Juno spacecraft, currently orbiting Jupiter as a possible platform to observe or intercept a passing interstellar object. Juno was not built for that mission, but space missions have been repurposed before. And the calculations show that if the timing lines up, we might be able to redirect existing tools to catch a rare glimpse of one of these visitors up close. Just think about that for a moment. A spacecraft we built decades ago for a completely different reason may end up being the first tool humanity uses to meet an object from another star system in real time. That is not a small thing. That is the kind of moment history books remember. And then there is the deeper, quieter question underneath everything. The one nobody wants to say out loud, but that keeps coming back. What if we are not alone? Voyager 1 and Voyager 2 have already left our solar system. Pioneer 10 and 11 are drifting into the dark. New Horizons is on its way out too. Each of these carries information about us, our location, our sounds, our images, our story. If another civilization out there has developed the same kind of sky scanning technology that we just built, they may have already noticed us. Not by radio signals, not by television broadcasts, but by watching one of our own probes fly through their neighborhood. That thought is both wonderful and unsettling, because it means the moment we developed the eyes to see interstellar objects, we may have also given other eyes the chance to see us. Loeb has been arguing for years that we should not dismiss the possibility of alien technology drifting through our solar system, just because it is uncomfortable. He is not saying every strange object is alien. He is saying that when a rock behaves like a machine, and a machine is one of the possible answers, science must at least allow the question. Because ignoring it does not make us safer. Ignoring it just makes us blind. The scientific community's caution is a strength. It keeps us honest. It keeps us from wild claims. But the willingness to sit with hard, uncomfortable questions is also a strength. It is what allowed humanity to accept that Earth was not the center of the universe, that stars were suns, that galaxies were islands, that the cosmos was older than we ever dared imagine. Every one of those truths was uncomfortable when it first arrived, and every one of them turned out to be real. Now, before I take you into the final part of this story, the part that ties everything together, I want to ask something small of you one more time. If you have made it this far, you already know that this channel is not about hype. It is about the real questions, the ones scientists whisper to each other when the cameras are off. So if you value that, if you want more of this kind of storytelling, please hit that share button and send this video to one person who loves the mystery of space as much as you do. Every share is a quiet vote for curiosity in a world that too often chooses noise. And I appreciate every single one of you who does it. Now here's the part that keeps me up at night, the part that keeps a lot of scientists thinking long after their working hours end. If Oumuamua truly has returned, or if the new object entering our system in 2026 turns out to be something even stranger than what we have seen so far, then the entire story of these last 9 years has been building toward a single question. What is the universe trying to show us? Not in a mystical sense, in a very literal, scientific sense. Because if interstellar objects pass through here regularly, and if some of them behave in ways that our physics struggles to explain, then either our physics is incomplete, or the objects themselves are not what we think they are. Or both. And every one of those possibilities changes the story of humanity. If our physics is incomplete, we are on the edge of a new scientific revolution, one that could rewrite our understanding of motion, matter, and the shape of space itself. If the objects are not what we think, we may be sharing our galaxy with other minds, and we may be seeing the first faint traces of their existence in the strangest visitors that fly past our sun. Neither option is small, neither option is boring, and neither option can be ignored anymore. In just a few short years, we may have real answers. The Vera C. Rubin Observatory will catch more visitors than ever before. Project Lyra may be approved, Juno may be redirected, new instruments will come online, and every strange object that arrives will be studied harder than the last, because we now know that they are not rare. They are constant. They are common. They are part of the fabric of our cosmic neighborhood. And every one of them may be carrying a message we do not yet know how to read. The astronomers in Hawaii who first saw Oumuamua that quiet October night in 2017 could not have known that they were opening a door that has not closed since, a door that only widens every year. A door that might, one day soon, reveal something so profound that we will remember the moment we walked through it for the rest of our species' history. Maybe that day is far away. Maybe it is closer than we think. Maybe the object being studied right now, above our heads, in silent orbit through the outer dark, is exactly what many people fear it is. Or maybe it is just a rock, a weird, wonderful, ancient rock whispering old secrets from a place we will never see. But either way, one truth has already settled into the bones of modern science. And it is not going away. We are not alone in our solar system. Not because aliens are here, but because the universe itself keeps showing up on our doorstep. Ancient, fast, strange, patient, and endlessly curious about us in ways we may only just be starting to understand. And if you listen carefully to the silence between the stars tonight, you might feel it too. Something out there is moving. Something is coming closer. Something has already arrived. And the only real question left is not whether it is here. It is whether we are finally ready to see it.